Hey guys, so today you and I are going to talk about JSON schemas and MongoDB. So let's get into it. So the question in question was, Frederick, what's your take on JSON schemas for MongoDB documents? Do you think that it's sufficient enough for data uniformity, or do you just opt into MySQL or Postgres 100% of the time when data uniformity is needed? Well, I would say that I don't think I've ever been in a situation where data uniformity is not needed, but I think that the mistake here, mental mistake that this person may be making, is that the database has any bearing on data uniformity. From my perspective, it doesn't. You see, the the fact that you might use something like MySQL to have a structured schema to your database is really only helpful because it allows you to create a certain query that makes your operations actually more efficient, as opposed to with MongoDB, which is it's not going to be able to query as quickly for something like relations, like doing joins and so forth. And that's a big problem with MongoDB. On the other hand, there's a lot of benefits to being able to just dump things in as a JSON blob as well. But when it comes to data uniformity, these two databases, they sort of face the same sort of problems, because it doesn't really matter if you have a relational database or if you have a document database. If you're looking to have an inconsistency in that database, let me explain that a little bit. Because the thing is, guys, if you go and use Postgres as an example, you can actually store JSON data as a column. You can express that. You can simply add that to your schema and say, hey, this is JSON data. And by definition, that means that now, well, you can't query as efficiently as you can with it as in MongoDB. Of course, you can't like go in and query specifically on that JSON data, but you can store it, which means that you can now have unstructured or ununiform data that you can serialize up. And now when that you can serialize. And what that means is that now that you have that unstructured data format in your relational database, you now have to take responsibility at the application layer to know how to convert that information into code, or into something that makes sense in your code. Because usually there's only two things you're going to do here. Either you need that JSON data to be in a format that you can actually serialize into deserialize into a model of some sort, and then now you actually need to know what does that JSON data look like. Or you don't care about it, you're just going to send raw data. An example of that would be you have some external system that you're just going to proxy that data to. And if you think about that, then you'd never have to know what shape the data is in. If you don't have to deserialize it into a data structure, then it doesn't matter what shape it is in. So data uniformity doesn't really matter. But in the case of, right, you need to be sure that all of these records that you have in your database, be it Mongo or be it MySQL or Postgres, they are uniform. They follow the same schema. Well, that's still an issue for you in Postgres, because even though you can at the database layer guarantee that if you try to push some data into that database, it's going to yell at you and say, hey, you can't insert a record that looks like that. That's like the one benefit of this. Having the schema guarantees you that you can't by mistake put something in there that it's not supposed to be. That's not the case for MongoDB. You could, in theory, you can enforce this as well if you really wanted to, but you could in theory have a record where a certain property on that document is, in one case it's a string and in one case it's an int, or like an integer or just a number, right? And that's not great. But I think that that is less of a problem. I think that we give that to more value than it's actually due, because it's not that often that this sort of thing actually happens. Because remember, you have an application layer most likely on top of all of this, and if your code is working, you should never be in this situation, because as I said, if you're in this situation, well, then you can deserialize this data without having to check is this property the thing that you want it to be. And that's not, as I said, it's not the thing you usually do. The thing that is really a problem when it comes to data uniformity is migrations. And in my opinion, that is an equal problem regardless of if you have a relational database or if you have a document database. It's the same problem, and it's still complicated regardless of which one you go with. Now let me explain the problem with data migration. So the problem with data migration is that you really only have two ways of solving this problem. One is that you need to stop the system, because as you can imagine, this is the classic thing you do with relational databases. You do a migration, you create a migration script that basically runs, you run an SQL query against your database and simply update all the records. The problem with that is that that's only possible to do if the system is down. Because as you can imagine, people, if you start updating your records, you can't really be guaranteed that there's nobody in between there while you're running this migration that isn't going to start adding records, and that's going to break. So you're actually not going to be able to have people write to that database. And in some cases, they might not even be able to read from it until the migration is over. And if you have a really big one, it might take a while. And in this day and age, we have decided that high availability is more important than anything else. And so having basically 100% or close to 100% uptime is the thing that we're going for here. So this is usually not that feasible, unless of course you know that you have peak hours and low traffic hours and so forth. There are absolutely situations when this can work, and if you can do this, if you're dealing with records in a database that isn't that frequent, that it doesn't have all that much traffic, then it's perfect. This is my absolute favorite solution in that scenario, because it's you fire it once and then the problem is over. But that problem is identical in a relational database to a document database such as Mongo. Because, as I said, just because you can store whatever shape you want in MongoDB, it doesn't mean that you actually want to, or that it's actually smart. So the other way of doing it is to deal with a rollover type of thing, where you're doing it in an iterative fashion. And what you do then is that you create logic in your application that looks at the records, where maybe you want to go from one shape of your data to another shape. Well, then when the database is actually being connected, you read up that information as just raw information, usually a string, and then you parse it, and then you, in your application logic, you look, is this an old record or is it a new record? If it's an old record, well, then just we need to actually migrate it. So if it's an old record, you need to migrate it. If it's a new record, you can just return it to the user. So when there's an old record, you just shape it into the new format, and then you persist it in the new format. And what that gives you is a way to never go down. You can because you can actually run, you're backwards compatible, if that makes sense. You don't have to pull down the system. You can just update your application logic, and now it can handle both records. But the problem here is that is a very dangerous thing to do as well, because now you don't actually know what state your database is in. It's not uniform anymore, as this subscriber is talking about. But sometimes you can't get away from this. Like, your database is now in an inconsistent state. And the same thing goes for a relational database. If you have to make this database migration, you will have to have like optional rows and optional fields for a long time, because there's no way for you to get around that. So what I want you to take away from this is that data uniformity is an issue in every database, practically, unless, as I said before, you're in a situation where you don't care about deserializing that information into models or anything like that. If you're just dealing with raw JSON data, for example, it doesn't matter what database you have. You can have anyone. And sure, there are small perks to having a schema that you can enforce, but as I said, it's not that big of a deal. It's very rare that you by mistake have these issues in MongoDB. And trust me, I've worked with Mongo for many years now. It's not the way that you might think it is. On the other hand, the thing that they both share that is a real problem with data uniformity is the migration. And the migration problem is a big problem, because if you need to go from one data shape to another data shape, you're going to have to think about how to do that. If you're really lucky, you can run a migration job and just do the whole thing without anything without any problems, and now you're in the new state. The whole database is clean and nice in the new schema. But if you can't do that, you have to do a iterative approach, and that's a much tougher thing to do, because now you need to support that there are records that are old in the old shape and there are records in the new shape, and that's a very tricky problem to solve. And that is the same problem regardless of if you're in a relational database or in a document database. So I don't think that the database makes all that much of a difference when we talk about data uniformity. Have a great day.